Okay, today we're gonna concentrate on jump discontinuities. So the plan is to know how to evaluate the graphs, domain, and range. So the first thing we need to address is what exactly is a jump discontinuity. So I'll explain this with this visual here. So suppose that we have a continuous graph, and then all of a sudden it has a hole. But let's say that the graph continues at this other point now. So you can kind of see that this hole, right, the value that or the value that was supposed to be inside is now here. And now the graph continues with a separate piece. So more or less you can have a piecewise function here, and you can see that it jumps from one end to another. So now let's evaluate these graphs. But before we evaluate them, I want to make one thing clear. Whenever we have an open hole, we say that the value is not a solution, and we say that the one that's closed is the solution. And you'll understand what I mean in just a bit. So let's take a look at an example. So here we want to evaluate this graph. So let's begin by evaluating -6. So we have to look at the x-axis here, and we have to look for -6, and you see that -6 is right here, and the y value that corresponds to -6 is going to be +3. So f of -6 is +3. Let's evaluate f of -3 now. So we have to go to the x-axis and find -3. And now we have to see what y value corresponds to this -3. So let's see where on the graph it hits. So it gets hit right there. And the y value that corresponds to the point on the graph is -3. So f of -3 is -3. Now let's take a look at f of -2. This one's going to be the interesting one. So now we look at -2, and you see that we have, at first glance, we may think that we have two values. We have this one, and we have that one. But remember to what I said on the previous slide. So I mentioned that here, the one that is open is actually not going to be a solution. We want the one that's closed. So here, we're going to ignore this one because it's a hole, and we're going to approve of this one, the one that's closed. So f of -2 is going to be +2 here. And now let's get the last one, f of 3. So f of 3 is actually going to be +2 as well. And there you go. Let's try one more. So in this scenario, we have 3 pieces, but the same principles apply. So let's look at -5 first. So let's label our x-axis and look for -5. -5 is right here, and the y value that corresponds to this x value is going to be -3 here. So we get -3. Let's evaluate f of -3 now. So here we see that we're in this scenario where we have a open hole and we have a closed hole. And again, we want to get the one that's closed. So f of -3 is going to correspond to -2. And now we have to evaluate f of 0. 0 is the origin right here. So at the origin, the y value is also going to be -2. Let's evaluate f of 3. So f of 3, we got to look for 3. And we have a closed hole, we have an open hole. We want the one that's we want the one that's closed. So here we're gonna ignore -2 and approve of +1. So f of 3 is positive 1. And then finally f of 4. 4 is right here. So let's see what value gets hit on the graph. And the y value that corresponds to this point is going to be positive 3. So f of 4 is positive 3.